Hi, welcome back. And today's lecture series, we are going to see about the protection of alternator in Unit 3. So, the protection of alternator. So, normally in generating units like a Neyveli power plant, nuclear power plant, Kodangulam power plant, Neyveli thermal power plant, like you can go any generating plant, generating unit. So there especially a larger one alternator is there. It is only few number. It may consist of only one alternator or two, or only a few number of alternator is available in the generating unit, but the few in number of generator is very large size, which is very larger one. And also the cost of the alternator or generator is also very high compared to the other equipments. So our alternate objective is, it is desirable and necessary to provide the protection to cover the wide range of fault which may occur in the modern generating plant in the alternator or generator. So these are the few important fault which may occur on the alternator. So one is the failure of prime mover, failure of field, and due to overcurrent and due to overspeed and due to overvoltage and due to the unbalancing load and stator winding fault. So these are the different types of fault which may occur on the alternator. So the alternator may gets damaged. So the few types of fault which may affect the alternator. So the first one, the failure of prime mover. So when the input to the prime mover is fail, what is the input to the when input to the prime mover? So for example, if you take an alternator, so the alternator input is mechanical energy. The mechanical energy which is supplied from the prime mover. So the prime mover, it may be either petrol engine, diesel engine, gas turbine, hydraulic turbine, steam turbine, etc. So the mechanical energy provided by the prime mover. Once if the prime mover gets a failure, so that the alternator run as a synchronous motor. So that the alternator is run as a synchronous motor. So we are not producing the power. Instead of not producing the power, just we are consuming the electrical energy from the grid supply, and the alternator is act as a motor. So it runs some current from the supply system. So this is a motoring condition, or it may be called as inverted running of an alternator. So this is the one problem. And another one, failure of field winding. So the chances of field failure of alternator are undoubtedly very rare. It is very rare, the failure of field. But even if does occur, no immediate damage will be caused by permitting the alternator to run without a field for a short duration, for a short period. Okay, and it is sufficient to rely on the control room attendant to disconnect the faulty alternator manually from the system bus bar. Therefore, it is universal practice not to provide automatic protection against the contingency. So that is very rare fault. It is because of the failure of field winding. And the alternator failure due to the overcurrent. So it occurs mainly due to the partial breakdown of winding insulation or due to the overload of the supply system. For example, during the peak hours, especially in the morning as well as the evening hours, so when the number of loads which are connected to the power system and the number of loads which is turned on is very high. So if the loads are increases, so it drawn more current from the source. The source is nothing but alternator. So it drawn more current. The more current is nothing but an overcurrent. So because of this overcurrent, the alternator it try to produce the required amount of current to the load, but it is unable to produce. So because of this overcurrent protection of alternator, it is unnecessary. Because if the load is increases, the generated speed gets changes, and some the automatic control system will takes place. And the next one, overspeed. So the overspeed is related to the overcurrent, like with respect to the load. Here, the chief cause of overspeed is the sudden loss of all or major part of the load on the alternator. Suppose the number of loads are connected always. That may be small or it may be big, whatever it may be. But an huge load, if it is suddenly disconnected, so the heavy current, the certain amount of load is disconnected, so that the voltage and the current will be increases. So it affects the generating station of the alternator. So because of the increasing voltage and current, the speed of the alternator gets increases. Once the speed is increases, the frequency is also changes. So it's while if you are disconnecting the heavy load, the speed is increases, and if you are adding the heavy load which is connected on, and the speed will be decreases. So with respect to load, the speed will be changed. So the overspeed, it may affect the alternator. And over voltage. If the field excitation system of modern alternator is so designed, and over voltage condition at normal running speed cannot occur. However, over voltage in an alternator occur when speed of the prime mover increases due to sudden loss of the alternator load. Last we seen, if the heavy load is disconnected, the over speed is because the current will increase, that is overcurrent, and the voltage will increase, over voltage, so that the speed will increase. That is nothing but an over speed. Okay. And unbalanced load. So unbalanced loading means that there are different phase current in the alternator. So if unbalanced load arises from fault to earth or fault between the different phases of the alternator. And the next one, stator winding fault. So here this fault occurred mainly due to the insulation failure of the stator winding. It is mainly fault between the phase to ground, and fault between the phase to phase, and due to the interturn fault in the same winding. And there is an assessment. Can you answer for this question? In an alternator, the voltage of the field is usually more than 1000 volt, between 400 to 600 volt, and less than 200 volt, and none of the above. So put your answer in the comment section. And these are the few textbook and reference books. Thank you.